Hello and welcome back to our next installment of our YouTube mini lectures. This one is entitled Translation Express, and for this mini lecture there are 3 pages. So page 1 is this one, page 2, and page 3. Okay, so let's begin. All right. So in this first panel right here, we have the 3 major players in translation. Okay, so 1, we have the ribosome. And the ribosome exists as 2 separate pieces before it assembles during the process of initiation. There is the large subunit, which I illustrate to kind of look like a hamburger bun, the top part of a hamburger bun, and the small subunit, or SSU. All right? Now, this piece down here, this is the messenger RNA. And the mRNA is a single-stranded nucleic acid that has a 5' end and a 3' end. And I want you guys to go ahead and follow along with me and write this sequence, this RNA sequence, on this mRNA right now. AUG, GCA, ACG, UAA. All right, so that is our sequence from the 5' to the 3' end. And then the third component to this, these 2 little pitchfork-looking guys, this is my representation for the tRNAs. All right, so we have ribosome, mRNA, and tRNAs. So the 3 forks of this pitchfork-looking structure, this is the anticodon right here. So these 3 nucleotides, this is the anticodon region of a tRNA. And the circle, the square, these other geometric shapes on the other side of this representation of the tRNA, these are the amino acids. These are what are transferred by the tRNAs. Okay? So we begin with the process of initiation. And during the process of initiation, the ribosome and the first tRNA assemble on the mRNA. So the LSU and the SSU plus the tRNA with methionine, that superscript reads MET, assemble on the 5' end of the mRNA. Okay, so here's our LSU, our large subunit. Here's our small subunit. Here's the 5' end of the mRNA, the 3' end. All right, and inside the mRNA right here that spans across the ribosome, so this is the ribosome, right? The large subunit and small subunit. The sequence that fits inside are AUG, and let's see what else, GCA. That is what is the sequence found internal into the ribosome. So question for you guys, how many codons are inside of the ribosome? 1 codon and 2 codons, right? 2 codons. Okay, what's outside of the ribosome? What's the next codon? ACG, and then UAA, and then the 3' end. Okay, so this is the process of initiation. All right, so question, all right, if this is the codon here, AUG, what would be the complementary codon on the tRNA? Well, at the anticodon, if there's an AUG here, this would be a U, then an A, then a C. All right. So here in the next panel, we have the anticodon that's paired with the AUG, So AUG. And the anticodon of this tRNA, of course, is UAC. Those are the complementary nucleotides of this tRNA. Okay. Now, what is the next codon? The next codon is, of course, GCA. Okay. So what would be the anticodon of this tRNA that's going to come in and fit at this next site that's open in the ribosome? If this is GCA, this must be CGU. All right? So here, the process by which a tRNA comes in and binds to this next open site with its complementary, CGU, with the complementary sequences, this first step is called codon recognition. All right? And it's the first step of elongation. So first step of elongation, not of transcription, but of translation. All right? So the next thing which occurs, now we have these tRNAs that are adjacent to each other inside of the ribosome. All right? What is the name of the bond between amino acids? Peptide bond, right? So here, this arrow right here, this indicates that we are going to create a peptide bond. So let's label this step peptide bond formation. So first we have codon recognition, then peptide bond formation, and here we make a bond between the amino acids on these two adjacent tRNAs. So make a peptide bond between amino acids on tRNAs inside the ribosome. And the ribosome has enzymatic activity which is causing this to occur. All right? So we've got codon recognition, peptide bond formation, and now what's going to happen with this tRNA now that it's lost its amino acid head? It's going to get the boot. All right? So this tRNA lacks its amino acid head and gets kicked out. All right, so it leaves. And now this tRNA in this position, this entry position, has two amino acids on it. So two amino acids, and they're linked together via a peptide bond. All right, does that make sense? This tRNA gets the boot. Now this tRNA has two amino acids attached to it. Now the next major step that occurs is we have to go down. This ribosome reads the mRNA from the 5' direction from the 3 to the 3' direction. So 5', 3'. If inside here the sequence was AUG, GCA, on this portion right here, and outside there's the ACG, what we want to do is we want to move this one codon down. So here, we're going to illustrate this happening. All right? So 5' end, 3' end. Now the AUG is outside. The GCA is the mRNA sequence inside here. And now ACG is the sequence of this open position. All right? So the movement, one codon down, this is referred to as translocation. So translocation describes the process by which the ribosome moves one codon down in the 3' direction. So the ribosome moves one codon in the 3' direction. All right? Now what are we back to? Now we're back to codon recognition. So let's put down in here in parentheses, repeat, codon recognition. So if this is ACG here, what is the anticodon on this tRNA? It would be UGC. Okay, it enters the ribosome. What's the next step that happens after codon recognition? Another peptide bond formation. All right, so codon recognition, peptide bond formation. What happens to this tRNA? It loses its head, it gets kicked out of the ribosome. And then what do we do next? We repeat. So go on to another translocation. And then you repeat this process X number of times. Okay, so finally what's going to happen? Finally, the ribosome is going to reach a stop codon. So if out here was AUG and GCA and ACG, and if this next codon is one of our 3 stop codons, all right, what is our stop codon here? UAA is the sequence here. That tells the ribosome to terminate. This is a stop codon. So this step, termination, occurs when the ribosome reaches a stop codon. Okay, now once it reaches the stop codon, the ribosome disassembles, the mRNA is free again, it can be translated again by another ribosome. The tRNA is released, and the polypeptide is released. So let's label this. This is a newly translated polypeptide. And it can go off, and it can folds into a functional protein. And there you have it, the process of translation express. Well, translation, but here I have cartoonified it for you to make the process a little simpler. All right, until next time.